Okay, in this podcast we're going to talk about quantifying the concentration of solutions. We can talk qualitatively about solutions. We can say that they're dilute or they're concentrated. Dilute means that there's a little bit of solute in the solvent. And concentrated, of course, means there's a lot of solute in the solvent. But we can also talk about them quantitatively. We can actually put numbers on them. And the two terms that we use to do that are molarity, which is a symbol of big M, and molality, which is a small m. So words that look alike, sound alike, the only difference is the T and the L and the R. So it's important to know which is a big M and which is a small m because we use those as symbols. Okay, so let's go ahead and just start on problems with molarity. Alright, so molarity is defined as the moles of solute, the stuff I'm dissolving, per liter of solution. So if we have a problem that's given to us, let's say, where we have to determine the molarity of a solution in which 88 grams of sodium chloride are dissolved in 0.75 liters of solution. Okay, so what we just said was the formula is molarity, capital M, is moles of solute per liter of solution. Alright, so let's see what we know. We know the liters of solution, right? So we know this is 0.750 liters. And we're not given moles, but we are given that we have 88 grams of sodium chloride. So we can figure out moles because we have 88.0 grams of sodium chloride. And what we know is 1 mole of sodium chloride has a molar mass of 58.44 grams of sodium chloride, and this gives us 1.51 moles of sodium chloride, and this is the solute, so this number goes up here, 1.51 moles. Okay, if I divide those two numbers, I get 2.01. I want 3 sig figs because that's what I have in both of my givens. 2.01, we say it's a 2.01 molar solution of sodium chloride. This is the way we'd write it, 2.01 capital M NaCl. Alright, let's take a look at another. Alright, here we want to know the molarity of a solution in which 10 grams of silver nitrate are dissolved in 500 milliliters of solution. Alright, we can write the formula again. Molarity is moles over liters. I know that I've got 500 milliliters and there's 1,000 milliliters in a liter, so that's going to be a 0.500 liters. And if I have 10 grams of silver nitrate, 10.0 grams of silver nitrate, and what I know is 1 mole of silver nitrate has a molar mass of 169.88 grams of silver nitrate. Whoops. And this is going to give me, let me see, 0.0589. I want to go at least to 3 sig figs moles of silver nitrate. So I can put that number up here, 0.0589 moles. And if I divide those two, I get 0.118, and that'd be molar silver nitrate. Okay. Here we're asked how many grams of sodium hydroxide are needed to make 1.25 liters of a 0.4 molar solution. So let's take a look. We got the formula. Big M is moles over liters. We're asked for grams. Well, let's fill in what we know. We know the molarity is 0.400. We don't know moles, but we do know liters, 1.25. Okay, so we can get moles by cross multiplying 0.4 times 1.25, and that's going to give us like 0.500 moles. Okay? And what I want is number of grams. So it's sodium hydroxide. So that many moles of sodium hydroxide, and what I know is 1 mole of sodium hydroxide is 40.0 grams of sodium hydroxide. And if I multiply this out, I get 20.0 grams of sodium hydroxide, 3 sig figs. Okay, we got one more problem here before you do the practice. Alright, so to what volume should 10 grams of sodium nitrate be diluted to make a solution of 0.47 molar solution? So here I'm trying to find my volume, okay? And I've got my molarity, which is 0.47, right? I can figure out my moles because I've got 10, let me see, where's my 10.0 grams of sodium nitrate. And what I know is 1 mole of sodium nitrate is 86.99 grams of sodium nitrate. And this is going to give me 0.115 moles. I'm going to put that here, 0.115 moles over liters. Okay, so if I cross multiply, I get 0.47 times liters equals 0.115 moles. I can divide both sides by liters, and when I do that, or divide both sides by 0.47, silly me, 0.47, because I want liters alone, and that's going to give me liters is equal to 0.245 liters. Okay, so you should work on the worksheet, the molarity worksheet.